In the previous video, we already learned about how to solve exact differential equations. Okay, we looked at very detailed steps of those and some examples. In this video, we'll look at how to solve non-exact differential equations. Okay, we solve non-exact differential equations by converting them to exact by finding something called as integrating factor. Okay, let's look at what we mean by this. Let's say the differential equation that we want to solve is of the form m dx plus n dy is equal to 0. Okay, here remember that m is a function of x and y, and even n is a function of x and y. M and n both are functions of x and y. Okay, if the differential equation was exact, derivative of m, partial derivative of m with respect to y, and partial derivative of n with respect to x, these two partial derivatives would have come out to be equal. But if the differential equation is non-exact, that is what we are looking at right now, we will see that these two partial derivatives won't be same. So first thing that we'll do to solve is to find those two partial derivatives, just like we did in exact. We'll find those two partial derivatives, delta m by delta y and delta n by delta x. And if they come out to be non-equal, we know that differential equation is non-exact and we have to reduce it or convert it to exact. What are the steps to convert it to exact? There are some rules that we follow that we'll learn about shortly, but there are some steps to follow. Okay, step number one is using the rule, using the rules that we will learn. Find the integrating factor. Find integrating factor. What are the rules? We'll just look at it in the next slide. Okay, but remember, using the rules, find integrating factor. Next, next step is multiply by integrating factor. Multiply by integrating factor on both sides. Multiply by integrating factor on both the sides. Okay. And step 3, equation is now exact. Once you multiply by integrating factor on both the sides, equation becomes exact. Equation is now exact. Solve as usual. Solve as usual. We'll just solve like we solve exact differential equations that we learned in the previous video. Okay, we'll still look at that in detail even in this video. Okay, let's look at the rules. The important thing that we want to learn now is what are the rules to find integrating factor? What are the rules that we use to find integrating factor? Now there are 4 rules that we have to remember in order to find integrating factor. Rule number one, if delta m by delta y minus delta n by delta x, you take that difference. You take the difference of two derivatives, delta m by delta y minus delta n by delta x, and you divide that by n. You divide that by the latter term, n. Okay. If this whole term is a function of x, if this whole term is a function of x, so if delta m by delta y minus delta n by delta x divide by that n function, is if this whole thing is a function of x, then that implies integrating factor is e to the power integration of fx dx. Okay, that's the rule number one. If we notice that this difference divided by that n is a function of x, then integrating factor is e to the power integration of fx dx. That's the integrating factor. Rule number two is very similar to rule number one. Okay, it's just the reverse of this. Okay, if so, instead of taking delta m by delta y first, if I would have taken delta n by delta x minus delta m by delta y, can you guess it? We divided by this term, second term m. If this come out to be, if this whole thing come out to be a function of y, okay, a function of y means it doesn't contain x. Okay, here function of x contain means it doesn't contain y. If this come out to be function of y, you can guess that integrating factor is equal to e to the power integration of fy dy. Very simple. Rule number three is, let's say if equation is of the form m dx plus n dy is equal to 0. That's the normal form of the differential equation that we solve. But here m is, so here since it is dx, if m is y times function of xy, y times, note that this is not x comma y, this is function of x into y. Okay, so if m is y times function of xy and n is x times some other function of x into y. Okay, if this is the situation that m is y times, if it is dx here, it should be y times for some function of xy, and for n it should be x times some function of xy. Those two are different functions, f1 xy, f2 xy. If this is the scenario, then our integrating factor is 1 upon mx minus ny. 1 upon mx minus ny. Remember that since mx minus ny is in the denominator, it cannot be 0, where mx minus ny is not equal to 0. That's our integrating factor. Okay, the last rule. Again, if the equation m dx plus n dy is equal to 0, if equation is of this form, m dx plus n dy is equal to 0, and from here, if you try to find dy by dx, and if you try to find dy by dx, and if dy by dx is homogeneous, if dy by dx is homogeneous. Okay, we'll look at what is homogeneous while solving the questions. But if dy by dx is a homogeneous function, if dy by dx is a homogeneous function, then our integrating factor will become 1 upon mx plus ny. Integrating factor will become 1 upon mx plus ny, and where mx plus ny is not equal to 0, obviously, because it's in the denominator. These are the four rules really of finding the integrating factor. Very simple so far. Okay, now let's look at some examples. Let's look at some examples. Okay, remember that these are the rules to find integrating factor. So that's step number one. Using rules, we find the integrating factor. Step number two is multiply integrating factor on both the sides of the differential equation. And once you do that, the moment you do that, the equation, the differential equation that you have will become exact, and we'll just solve it like an exact differential equation that we have done in the previous video. Okay, very easy steps to follow. Now let's look at this example. We have m dx plus n dy. So this is of the form m dx plus n dy, where if you notice m is equal to xy square minus e to the power 1 over x cube, and our n is minus x square y. Okay, don't forget that minus. We have minus x square y as our n. We take two derivatives as always. We take derivative of m with respect to y. Okay, derivative of m with respect to y. With respect to y, x is constant. Okay, derivative of y square is 2y, and minus derivative of this with respect to y is 0, because this is a function of x. Okay, so we have 2xy. Okay, derivative of m with respect to y is 2xy. Now let's look at derivative of n with respect to x. Derivative of n with respect to x. With respect to x, y is constant. With respect to x, y is constant. Derivative of x square, even minus is constant. Derivative of x square is 2x. So we have minus 2xy. So those two are not equal. Delta m by delta y and delta n by delta x. Those two are not equal. That means the equation is not exact. But we can reduce it to exact. How can we reduce it to exact? Let's take the difference delta m by delta y minus delta n by delta x. Okay, let's take that difference. So if you take the difference, this is 2xy minus 2xy is equal to, so this will become 4xy. This will become 4xy. Notice that now what you have to observe is that the moment you calculate the difference, the moment you calculate that either difference, if this is the difference, you divide by n, and this, if this is function of x, then this is the integrating factor. So now if you notice this, if I divide this value by n, is that a function of x? If I divide that by n, is that a function of x? Or if I divide that by m, will that become a function of y? Okay, if you notice, if you divide these two, the y and y will get cancelled. The y and y will get cancelled, and this will become function of x. But if you divide this one and m, nothing will get cancelled, and it won't be a function of y. Okay, so you have to actually see that if you the difference that you have got, if you divide it by either m or n, are you able to obtain a single function of either x or either y? Okay, so here I notice that therefore delta m by delta y minus delta n by delta x, if you divide that, by n, if you divide that by n, we get 4xy in the numerator, and the denominator is minus x square y. And things will get cancelled here, and you will get minus 4 upon x. You will get minus 4 upon x. So this is a function of x. Okay, this is a function of x. If this is a function of x, we know that this will follow rule 1. We know this will follow rule 1. Okay, and the integrating factor is e to the power integration of x fx dx. So integrating factor is integration of e to the power integration of fx dx. So this is equal to e to the power integration of minus 4 upon x dx. Okay, this will become e to the power minus 4 is constant, can be taken out of integral. Integral of 1 upon x is log x or ln x, natural log of x. Okay, all right, that makes sense. Now this minus 4 can be taken in the numerator by log property. Sorry, not in the numerator, in the power of that x. Okay, so this will become, let me scroll a little bit down. So this will become e to the power log x to the power minus 4. By property of log, this minus 4 can go on top of that x. So this will become, now since this is e and this is since a natural log, the base is also e. Okay, for natural log, the base is e. If this value and this base e is equal, we know that these two kind of get cancelled and we are just left with x to the power minus 4, which is nothing but 1 upon x to the power 4. Now that is our integrating factor, 1 upon x to the power 4. The moment we find integrating factor, we have to multiply. If you remember the steps, we have to multiply by integrating factor on both the sides. We have to multiply by integrating. So we take the differential equation, we multiply by integrating factor. So let me just copy that differential equation. Let me just copy that differential equation, and we paste that differential equation down. Okay, and we multiply both the sides by integrating factor. So I just write multiply by integrating factor on both the sides. So you get therefore 1 upon x to the power 4. So you get 1 over x to the power 4 xy square minus e to the power 1 upon x cube times dx minus 1 upon x to the power 4 x square y into dy is equal to 0. Now we know once you multiply by integrating factor, this is an exact differential equation. At this point, this is an exact differential equation. Let's just simplify this a little bit. Just multiply this inside. So we have y square divided by x cube, y square divided by x cube minus e to the power 1 upon x cube divided by x to the power 4 dx minus, this will become y upon x square dy is equal to 0. Okay, now this is, since we know that once you multiply by integrating factor, the differential equation is exact, we can just say that solution is, we can just say that solution is integration of m dx plus integration of n dy is equal to constant c. That's the solution. But remember now that this is your m and this is your n. Okay, also one thing, if you remember from the previous video, that in m we treat y as constant, and here we take the terms free from x, terms free from x. Okay, very easy so far. All right, let's treat y as constant and integrate. So we have integration of y square upon x cube minus e to the power 1 upon x cube divide by x to the power 4 times dx plus integration of, take only the terms free from x. N is this, take the terms free from x. There are no terms which are free from x. If you notice, there is only one term in n. In n we have y upon x square. So here in n, we only take the terms free from x. Since in n, there is no term which is free from x. There is only one term which contains x square. Okay. So this will just become 0 dy is equal to constant c. I hope that makes sense. Uh, Now let's try to solve that integral. Remember, in the first integral, we treat y as constant. Okay. So we have integration of, split that integration, y square upon x cube dx minus integration of e to the power 1 upon x cube divide by x to the power 4 dx. Okay. And this is equal to constant c. So therefore, y is constant. So we have y square integration of 1 over x cube dx. Okay. And in the second integral, we have to do method of substitution because this is a composite function. If you put 1 upon x cube as t, 1 upon x cube as t, somewhere you will get 1 upon x to the power 4. Okay. We'll have to do method of substitution that we have studied. So like actually, let's first do that. Let's first do that. So let's say here, let 1 upon x cube, let's say that is t. So therefore, differentiate this with respect to x. So you get so this is just like x to the power minus 3 is equal to t. Now differentiate with respect to x. So you get minus 3 x to the power minus 4 is equal to dt by dx, right? Just using normal differentiation technique. So therefore, I have minus 3 upon x to the power 4, because this x to the power minus 4 can be written as 1 upon x to the power 4. This is equal to dt by dx. Therefore, here we need to find dx divided by x to the power 4. Okay, so just take this dx over here. So we have dx divided by x to the power 4 is equal to minus dt upon 3. Okay, so that's the equation that is left over to me. So now what do we have? So we have here in the first integral, y square is constant, can be taken out of integral. Okay, we are left with integration of 1 upon x cube dx minus, we can convert this now in terms of t. We have integration of e to the power t. We just have e to the power t over here. And this dx upon x, we have dx upon x, sorry, dx upon x to the power 4 is minus dt upon 3. So this is minus dt upon 3. Remember that t is 1 upon x cube, and this is equal to c. Now, very simple integral at this point, y square integration 1 upon x cube can be just written as x to the power minus 3 dx, and this negative will become positive integration 1 upon 3 can be taken out, e to the power t dt is equal to c. All right, very easy so far. So therefore we have, therefore y square x to the power minus 3, the integration is x to the power minus 3 plus 1 upon minus 3 plus 1 plus 1 upon 3. For integral e to the power t, we know integral is e to the power t is equal to constant of integration c. So therefore we have y square x to the power minus 2 over minus 2 plus 1 upon 3, and we know that t is equal to 1 upon x cube. So t, we can substitute 1 upon x cube is equal to c. If we want, we can simplify this a little bit. So therefore we have therefore minus y square upon 2x square. This x to the power minus 2 can be taken in the denominator, plus 1 upon 3 e to the power 1 upon x cube is equal to constant of integration c. And this is our solution. I hope this makes sense to all of you. All right. All right, let's look at this next example. We have, this is our m, we have, this is our n, right? Uh, so we have m is equal to 2x y to the power 4 e to the power y plus 2x y cube plus y. Okay. And our n is x square y to the power 4 e to the power y minus x square y square minus 3x. Okay, let's take the difference or the derivatives of m with respect to y, and let's see what do we get. Now with respect to y, x is constant. With respect to y, x is constant. So we have 2x which is constant. Now we have to take the derivative of this with respect to y. Okay, so we'll have to apply the product rule or the UV rule here. Okay, so we have y to the power 4 constant. Derivative of e to the power y is e to the power y plus e to the power y constant, and derivative of y to the power 4 is 4y cube. Okay, plus we have this is 2x is constant again, and the derivative of y cube is 3y square plus here the derivative of y is 1. Okay, here since x is constant, 2x we kept as constant, and we differentiate y cube as 3y square. Okay, so just simplify this a little bit. So we have delta m by delta y is equal to 2x y to the power 4 e to the power y plus this 2x times this. So, and then that will become 8 actually because of that 4 and that 2. So that will become 8 x y to the power 3 into e to the power y plus we have 6 x y square plus 1. Okay, so that's the derivative of m with respect to y. It does look a little bit scary, but I promise you that it will be very easy once we solve it. It is not that difficult. Now let's take derivative of n with respect to x. Let us just highlight that derivative of m with respect to y is what we found. Let's take derivative of n with respect to x. So we have with respect to x, y is constant. So these two terms are constant. So we have y to the power 4 e to the power y. Derivative of x square over there is 2x. Derivative of x square is 2x because with respect to x, y is constant. Again, with respect to x, y is constant. So we have y square. Again, derivative of x square is 2x minus derivative of 3x is 3. Just simplify this a little bit. So we have delta n by delta x is equal to y2 x y to the power 4 e to the power y minus 2x y to the power 4 minus 3. Okay, so that's the value that we have. First thing that you do always is take the difference. You either take the difference of delta m by delta y minus delta n by delta x, or you take the difference of delta n by delta x minus delta m by delta y. Doesn't matter. Just take one difference and divide by either m, first divide by m and then divide by n and see what happens. Okay, let's see what happens. Let's first take the difference. Let's first take the difference of therefore, delta n by delta x, the value will become delta n by delta x will become 2x y to the power 4 e to the power y minus 2x y square minus 3. Okay. So in the end, we have to figure out whether it is rule number 1 or rule number 2 in this case. So basically, we have to figure out whether you have to divide by n or whether you have to divide by n. If you divide by n and it turns out to be function of x, then it is of this rule 1. If you divide by m and it is function of y, then it's rule 2. What you do, it's just the difference of two. It's the reverse difference, but it doesn't matter for now. It's just the difference. Okay. So for now, let's take a difference between those two derivatives. Sequence for now doesn't matter. We'll figure it out later. But for now, let's just take a difference. Okay. We are just figuring out. So I'll just use a different pen. Let's just use delta m by delta y minus delta n by delta x upon n, and maybe let's just calculate two values. Okay, let's just calculate delta n by delta x, delta n by delta x minus delta m by delta y divided by m. Let's see which of those two it is. Okay, let's see which of these two it is. If you take the difference of delta, so if you take a difference, this first term and the second term will get cancelled anyway. The second term you write, so 8x y cube e to the power y. Okay, I'll just circle whatever is done. So we considered this and this. Okay, then we have this. We considered this 6xy square minus 2. So we have plus 8xy square. So we considered this. Then we have plus 1 minus 3. So we have plus 4. Now divided by n. What is n? Divided by n. Let's just copy the value of n for now. Let's just copy the value of n from here and just paste it here. Let's see if anything is getting cancelled over here. Even if you take X common from here. I don't think anything will get cancelled. X y to the power 4. So this is not going to get cancelled. Okay, anyway. So that means let's discard this case and let's focus on this one. So let's just take the reverse difference. Okay, if it just take the reverse difference, it will just be a negative sign. Okay, so this will be -8 because it's you are essentially doing a minus b. You are just doing b minus a. So the result will be just negative of this. Okay, in the numerator. So 8xy cube e to the power y minus 8xy square and minus 4. And in the denominator, let's paste the value of m now. And let's see what will happen. Something magical is going to happen now. Let's copy that. Oops. Let's copy that and paste it over there. Paste it over there. And then if you take y common, so you get uh, 2x y cube e to the power y, okay, plus uh, 2x y square. Notice the pattern is coming out. The terms are same, plus 1. In the numerator, just take 4 common. In the numerator, just take actually minus 4 common. If you take minus 4 common, you'll be left with 2x y cube e to the power y minus, or sorry, plus, since you are taking minus common, 2x y square plus 1. If you notice, this term and this term will get cancelled and you will be left with minus 4 over y, which is a function of y. Now that we understand this is the second type, okay, which is delta n by delta x minus delta m by delta y. So let's just rewrite those things with a clean pen. Now that we know, that's what you'll do in exam too, okay? Just use the rough side of the page, use like a rough side of the page to to make a decision between that, okay? To make a decision whether it is delta m by delta y minus delta n by delta x or delta n by delta x minus delta n by delta y. So in this case, it is delta n by delta x minus delta m by delta y divide by m. Okay, and we already learned we got minus 4 over y. Okay, I'll just re-substitute everything here. So we have n by x. So this minus this will get cancelled. Minus 2, and this will become minus 8 x y square. This will become minus 8 x y cube e to the power y, right? And this will become minus 4. And in the denominator, we have m, which is essentially, we can just copy this really, copy that, paste it here. Oops, it didn't copy the entire thing, but in the end, we have plus y. Okay, let's take minus 4 common. So we have 2xy square plus 2 xy cube e to the power y plus 1. In the denominator, again, let's take y common. So we have 2xy cube e to the power y plus 2xy square plus 1. Okay, so this and this will get cancelled, and we have minus 4 upon y, which is a function of y. Okay, which is a function of y. So since this is a function of y, we can now say that therefore integrating factor is e to the power fy dy. Let's just write it in the next line. We can say that integrating factor is e to the power integration of fy dy, e to the power minus 4 integration of 1 upon y dy, because we just can take minus 4 common inside the integral. So we have e to the power minus 4 log y, okay, which is equal to e to the power log y to the power minus 4. This minus 4 can just go in the power of log by the property of log. Okay. Now, since this is a natural log, the base is e. Okay. So that the whole thing will get cancelled, and we have y to the power minus 4, which is 1 upon y to the power 4. Okay. Now that we have integrating factor, we can take the original equation and multiply that integrating factor on both the sides. So let's just copy the whole original equation. Let's just copy the whole original equation. Copy that, paste it here down, paste it here. Now multiply both the sides by 1 upon y to the power 4. So you can just write divide by y to the power 4 because you are basically multiplying integrating factor on both the sides. So just multiply by y to the power 4 on both the sides. I hope that makes sense. Now that you multiply y to the power 4, which is the integrating factor on both the sides, remember that the equation is now exact. Now that we know that equation is exact, we can just uh, do the solution as usual. Before that, let's just simplify this a little bit, and this will become therefore 2x e to the power y plus 2x divide by y, just splitting this y to the power 4 here, plus 1 upon y cube. Okay, this y and this y to the power 4, 1 upon y cube times dx plus plus. We have y to the power 4 here, so we'll get cancelled. So x square e to the power y minus x square divide by y square, okay, minus 3x divide by y to the power 4 dy is equal to 0. Okay, that's our differential equation, which is exact. So the solution is, now that it is exact, solution is integration of m dx plus integration of n dy is equal to constant of integration c. Okay. Remember that in the first term we have to keep y as constant, and in the second term take the terms free from x. Okay, take only the terms which are free from x, free from x, because we are integrating with respect to y. Take the terms free from x, and here with respect to x, just treat y as constant. So let's see, what do we have? We have integration of m dx. So just substitute the value of m. This is m. Okay, 2x e to the power y plus 2x divide by y plus 1 upon y cube into dx. Take the terms plus integration of, only take the terms free from x. Is there any term free from x? The first term has x, so it's not free from x. Second term has x, it's not free from x. Third term has x, so it's not free from x. That means there is no term in this entire n which is free from x. So we just take 0 here, is equal to constant of integration c. So therefore, just integrate this, keep y as constant. So 2e to the power y is constant. Integration of x is x squared divided by 2 plus y is constant. So 2 upon y is constant. Again, integration of x is x squared divided by 2 plus 1 upon y cube is constant. So 1 upon y cube. 1, integration of 1 is x. Okay. Plus 0 is just 0, and then is equal to constant of integration c. You can just cancel the small things here to make it simple, and therefore you have the solution x square e to the power y plus x square divided by y plus x upon y cube is equal to c. And that's your result that we are looking for, which is the solution of that differential equation. I hope that makes sense. All right, let's look at next example. Here we have dy by dx is equal to negative of this fraction over here. Let's just convert it in the form m dx plus n dy. So therefore we have, just multiply this over here. So we have, and multiply this over here. So we have minus x square y cube plus 2y times dx is equal to, okay, so minus of this entire thing into dx times dy times 2x minus 2x cube y square. Okay, so therefore just bring everything on the right hand side. So just take this negative on the right hand side, and you have x square y cube plus 2y times dx plus 2x minus 2x cube y square into dy. Now this is in the form m dx plus n dy. Okay, let's just take for exactness if it is already exact or not. Mostly it is not. Let's first see delta m by delta y respect to y. So x is constant. So you have x square, uh, 3y square plus 2. Okay, derivative of 2y is 2. And let's just differentiate n with respect to x. So you have 2, derivative of 2x is 2, minus, with respect to x, y is constant. So 2y square is constant. Derivative of x cube is 3x square. All right, so these both values are not equal, delta m by delta y and delta n by delta x. So obviously it's not exact. But if you notice a pattern here, if you just take y common from here, just take y common. So you have x square y square plus 2 dx plus take x common from here, take x common. So you have 2 minus 2x square y square. Okay, x common, 2 minus 2x square y square dy is equal to 0. If you notice something here, there is y along with dx, there is x along with dy. This is in rule number 3. I'll show you the rule, but y along with dx, x along with y, and this is a function of x into y. This is a function of x into y. This is also a function of x into y. Whenever this happens, if you go back to the rules that we have, whenever you have y along with dx function of x into y, x along with dy function of x into y, the integrating factor is straightforward 1 upon mx minus ny. 1 upon mx minus ny. So let's just find that integrating factor. So in this case, the integrating factor is 1 upon mx minus ny, which will become 1 upon, just take m into x. So this is our m, this is our m into x. So multiply that x here. So you have xy, x square y square plus 2 minus n into y. Just multiply y over here. So again, xy, 2 minus 2x square y square, which is equal to 1 upon, multiply these terms inside and simplify. X cube y cube plus 2xy, multiply this inside, minus 2xy plus 2x cube y cube. Okay, this xy times this. This and this will get cancelled. So this will become 1 upon 3x cube y cube. 1 upon 3x cube and y cube. That is our integrating factor. That is our integrating factor. Now we can multiply integrating factor on both the sides of this equation. We can multiply the integrating factor on both the sides of this equation. So just multiply that integrating factor. So you have y into, just take this equation and multiply 1 upon x 3x cube y cube. So y y square plus 2 divide by 3x cube y cube dx plus x 2 minus 2x square y square divide by 3x cube y cube into dy is equal to 0. That is our differential equation now, which is exact. We know that it is exact for sure because we have multiplied by integrating factor. Simplify this a little bit. So this will become y square. Cancel this. So this will become x square. Okay. So now this is like m dx plus n dy. Okay. This is our new values of m and n that we have over here. So now we can say that our solution, actually before finding solution, just split those values. Okay. Let's just split those values. So we have therefore x cube y square. Okay. So x square y square divided by 3x cube y square plus 2 upon 3 x cube y square times dx plus split this 3x square y cube over here, 2 upon 3x square y cube, then we have minus 2x square y square upon 3x square y cube dy is equal to 0. Let's just cancel the terms that we can. Y square can get cancelled. X square get cancelled and we just left with x here. And over here, x square get cancelled. Y square and this y left here. So therefore, our solution is integration of m dx plus integration of n dy is equal to constant. Okay. Remember, in the first term we have to take y as constant, and in the second term we have to take the terms free from x. We have to only take the terms which are free from x. Okay, so integration of, in the first term we have 1 upon 3x plus 2 upon 3x cube y square dx plus integration. Take only the terms free from x. There are two terms here. This term is not free from x, there is x here, but there is a term which is free from x, which is minus 2 upon 3y. Minus 2 upon 3y dy is equal to constant. Okay. Now just integrate that with respect to x. So we have 1 upon 3 is constant, 1 upon x, integration is log x, plus 2 upon 3 is constant, even y square is constant. And this is just like 1 upon x to the power 3, which is x to the power minus 3. The integration is x to the power minus 3 plus 1 upon minus 3 plus 1. I hope that makes sense. Basic rule of integration. 1 upon x to the power 3 is just like x to the power minus 3. Okay, so it's x to the power minus 3 plus 1 and minus 3 plus 1. Minus 2 upon 3 over here is constant. Integration of 1 upon y is log y is equal to constant c. Just simplify this a little bit and we have our solution. Log x divided by 3 plus 2 upon 3 y square x to the power minus 2, which is just like 1 upon x to the power 2, and this is just like minus 2. Okay, so we have just like minus 2, like this. Okay, minus 2 upon 3 log y is equal to c. You can just make this plus and make this minus now, and that's your solution of the differential equation. I hope that makes sense. Now let's move on to next example. If you notice this carefully, this is a homogeneous differential equation. Because the power of this polynomial is 4, power of this polynomial is 4, and power of this polynomial is 4. So that means that dy by dx term is homogeneous in this case. If dy by dx is, and how do we know it is homogeneous? The powers are same. Okay, this is the power 4 polynomial, this is power 4, and this is power 4. Whenever your dy by dx is homogeneous, basically whenever the power of all the terms in the polynomial is same, then the integrating factor becomes 1 upon mx plus ny. So that means dy by dx is a homogeneous function. So integrating factor becomes 1 upon mx plus ny. Okay. So straightforward, we can just say that integrating factor in that case is 1 upon, since uh, dy by dx or this differential equation is homogeneous. Therefore, we can just say that integrating factor is 1 upon mx plus ny, which is, so that will become 1 upon m into x. Just multiply that by x. If you multiply that by x, you will get x to the power 5 plus y to the power 4 into x, okay, plus ny, plus ny. So multiply this by y. So you get x into y to the power 4. But remember, there is a negative here. So this will become negative minus xy to the power 4. If you notice, this and this will get cancelled. This and this will get cancelled. And you have 1 upon x to the power 5 as your integrating factor. Very easy so far. Okay. So we can multiply by integrating factor on both the sides. Just so we have, just multiply everything by x to the power 5. So we have x to the power 4 upon x to the power 5 plus y to the power 4 upon x to the power 5 times dx minus x y cube divided by x to the power 5. So this will get cancelled and we left with power 4. okay, is equal to into dy is equal to 0. Okay, now this is exact. We know that this is exact for sure now. So the solution is integration of m dx, and this will become okay, this will become 1 upon x plus integration of n dy is equal to c. Okay, so in the first term we take y is constant, so keep y as constant. So we have 1 upon x plus y to the power 4 upon x to the power 5 dx. In n, take the terms free from x. There is no term which is free from x because you have x to the power 4. There is only one term. So we just have integration of 0 dy is equal to c. Okay, so far so good. So therefore we have integration of 1 upon x. We have log x or log mod x, whatever. Let's try log x plus y is constant. So we have y to the power 4. This is just like x to the power minus 5 because it's 1 upon x to the power 5. So this is just like x to the power minus 5. Integration is x to the power minus 5 plus 1 upon minus 5 plus 1 is equal to c. So therefore we have log x. This is minus 4. So this will just become minus y to the power 4 upon 4. And this will just become x to the power minus 4. So that's 1 upon x to the power 4. I hope that's making sense so far. That's the constant of integration c. And that's your solution of this homogeneous differential equation. I hope it made sense so far. Thank you for listening to till the end. If you have any questions, please feel free to post in the comments. I'll try my best to answer every single question that comes up. And thank you so much. Take care.